Hello everyone, again, hello. Welcome to the course again, and so let's make a real kickoff of the course. So again, my name is Tomiko Sakao from Linköping University in Sweden. So I'll be giving 10 lectures in this course. Pratul will give additional tutorials, which I will support him. And there will be a full opportunities of interaction between your side and our side. In this specific lecture, my expectation for your learning outcomes are, number one, you should be able to explain the backgrounds, especially industrial situations that are relevant to product service systems. Number two, you should be able to describe the why, the motivations, why industry is implementing or working for product service system. Number three, you should be able to comprehend, understand deeply different overall concepts of product service system. So in each of the 10 lectures of mine, I will show this kind of slide so that at the beginning of each lecture you will understand the learning outcomes expected from each lecture. All right? So a little bit of my introduction. I have been working in Sweden for the last almost 20 years. Before that, my education, university education, is all from at the University of Tokyo in Japan. And in between Japan and Sweden, I've worked in Germany for 2 years. In my university education, I did several different areas. My first journal publication was about qualitative reasoning, which is a particular area in artificial intelligence. Back in 1970s and 80s, 90s, qualitative reasoning was very attractive. Many researchers were working on that. There are still some groups working on qualitative reasoning, but that is what I sort of started off from. And then I also did some research on robotics. I presented a paper in robotics conference. And besides those, I've been working on design theories and also maintenance, design for maintenance, and so on. Right now, I'm active in CRP, which is the International Academy for Production Engineering. I'm one of the 3 fellows from Sweden, and I'm especially active in 2 areas. One is design. Together with 3 other colleagues, Daniel Brizot, Andreas Riel, and John Ökoyonchu, we published a keynote paper about product service design back in 2022. So 2.5 years ago, we published a state-of-the-art paper about product service system design, especially in the manufacturing context. The other area I'm active in is lifecycle engineering, environmental sustainability. About half a year ago, together with Nancy Bock and Nabil Nazrou and Yasushi Umeda, we published another keynote paper on circular economy implementation in manufacturing industry. I'm quite sure that you have heard of the term circular economy, which I will touch upon several times in the course. But I really recommend you to look for these papers, that they should be available. And those 2 papers give full of interesting insights from science and practice. But of course, I will be building upon these 2 papers and the other papers in this coming week. So a little bit of where I'm from. In terms of country, Sweden is often said to be a front runner when it comes to innovation in industry. It's often highly ranked in different international indexes, etc. And why does that happen? the national innovation agency, Vinnova, says that what they do involving us, research institutes and universities, is basically supporting needs-driven research and innovation. And they almost always sort of facilitate collaboration, competition between different actors, not only different institutes in the academia, but also among different sectors, like education, research, and of course industry and the public sectors, and so on. So this triple helix constellation is said to be a sort of key driving factor for innovation. When it comes to the city, my university is located in the city called Linköping, which is in between Stockholm and Gothenburg, or Stockholm and Copenhagen, if you know a bit better. The city is proud of a long history of innovation, actually. The city has telecom industry, and in relation to that, a lot of IT companies are based in Linköping. Some of them are spin-off from university researchers. And just as one example, a streaming technique used in Netflix is coming from the city. So there are a lot of companies based in Linköping, and the university is heavily working with them. These are the examples of the companies that my group closely works with, and I think you somehow recognize some of those company names and sectors. What is common to these companies is they produce products and also they provide services. And in some of the or most of the cases, the products are quite complex that require services from the OEMs. So this commonality makes us interested in doing research in product service system. And also, obviously, they are interested in product service systems. So please bear in mind, because when you hear from my talks and messages, then you might feel that, well, this is not so exactly relevant to your context in India, but that can be the case. But just please bear in mind that the knowledge that we have gained is largely based on the close collaboration with this kind of companies. But I'm sure that you will see a lot of useful insights, for sure. So, okay, from now, you will see 9 slides, each of which shows you different pieces of information regarding the relevance of product service system to industry from different angles. So the first slide shows you the mega trends that you must have heard and probably every day hear about. The first one is the societal demands for research and innovation has become so complex. So their needs and wants are multi-layered and interrelated with each other, so they are complex. For example, taking sustainability as an example, it has 3 pillars, as you know, environmental, social, and economic. So the sustainability challenge is very much outspoken nowadays, meaning that the challenges from societies to different organizations, especially companies, manufacturing companies, are so complex. It's a big challenge for each company to address the challenge. Number 2, no surprise, so digitalization. You hear about this every day. Huh? And from the research point of view, from the product service system point of view, this has given a huge opportunity. without digitalization, many things are impossible to do or even to think about. Huh? So these opportunities are so much enhanced over the years, and probably especially in the last 2 years or so, the accessibility of especially generative AI has made this opportunity so visible, more visible than ever. Huh? So you see these trends, two trends are interesting. On the one hand, you see a high challenges from industry, but on the other hand, you see a lot of opportunities from, for example, just as one major example, digitalization. So these two mega trends make us think product service system design so interesting. The second slide is a little bit of sort of addition to the previous one. So there are other trends and drivers relevant for PSS. These are more obvious ones, such as increased competition, customers' needs are also servitized, increased interest for the company to take over a larger part of the value chain. And I mean, typically companies want to specialize in certain things, and so on. So these more obvious trends and drivers are also supporting the trend of product service system and PSS design. So, looking at different countries, this is quite well-known result of survey, looking into how many percentage of manufacturing companies per country provide services. They are manufacturers, they do produce products. So besides the manufacturing, whether or not each company provides services or not. So overall, you probably see between, let's say, 20% and 60% of the manufacturers everywhere, they do provide services. So it's not a trivial thing for a manufacturer to provide services. It's an important part of their business. So when it comes to whether they make money out of providing services or not, and how much money they earn from service provision, is shown in this graph. This kind of data is rarely available. So I took this from Lodefak research result. He looked into the portion of the revenues of the manufacturing sector in Sweden. And you see the trends over the years. He looked into two different data sources, but both of them indicate a rather increase over the years. So when it comes to Sweden, the money manufacturing organizations earns from providing services has been increasing over the last years. So now it's, let's say, depending on the data sources, you could say above 20%, maybe close to 30%. Their revenue is from services, right? And then looking into when services take place, I think this is quite familiar to everyone. This is very old graph taken from 1998 from Harvard Business Review. This graph shows the profit margin from each phase along the value chain of typical products. This graph is made particularly for personal computers. So personal computers, they require first R&D and component microprocessor manufacturing, and then other components are also necessary to be produced, and then the final products, in this case personal computers, must be assembled. Thereafter, software industry and also peripherals, some other physical components used for the computer are also provided. And then this is where services comes into the business. So many people say that this follows a so-called smile curve because the profit ratio starts with high on the left-hand side and then goes down in the middle and goes up again on the right-hand side in the downstream of the businesses. And you see here, as I said, services take place at the downstream of the value chain, whereas the product provision manufacturing takes place in the middle. So this smile curve clearly explains the higher profit ratio of the service business compared with the manufacturing business. And again, I mean, I need to say this is a sort of a general observation. There might be exceptions, but this is quite a sort of valid in many cases, meaning that this is one of the strong reasons for why manufacturing companies have stepped into the service businesses and where they earn money. Okay? So looking into people, employees, occupations, this graph shows the data from US, looking into the employees' positions of a manufacturing organization, and depending on the type of the manufacturing organizations, the portion of service job positions differ a little bit, but roughly says that between 30 and 55% of the positions in a manufacturing organization are actually service-related jobs. And when you look up the global tech companies and also innovators, they have the highest portion, 55%. More than half of the jobs are about services in a manufacturing organization. So this also indicates the significance of service businesses in manufacturing, right? So now I think you hear what probably you have heard before by Levitt. So it's about drilling machines, and he said that what people want by using a drill is not a drill itself, but a hole made by a drill. This is so. This is implying so much different things. Products are a means, and an outcome of the products are different, and then people often want the outcomes of the products. And Levitt also mentioned that there are no such things as service industries because everyone is in service business. And it's amazing that Levitt mentioned this more than a half century ago. So it's so amazing, at least to me. But so the thing is, you probably use the term service every day in different contexts. But it's very important even for manufacturing companies, and because that creates business opportunities and profitable business and doing better businesses, right? So these are all sort of trends and interesting insights regarding the services, especially for the manufacturing businesses. And another piece of interesting information taken from a book named Industry X.0, published in 2017. So this graph visualizes what sort of sectors have sort of hidden markets, meaning that there are needs, but businesses are not yet materialized enough. And the axis shows the size of the market. And on the right-hand side, you see the value for industry. And on the left-hand side, it's rather value for society at large. So take a look at each piece shown on the sort of chart here. And you realize here product to services, right? So this is what I've been talking so far. And also sharing economy on the left-hand side is very much related to PSS. And you see those two areas are one of the most prominent topics areas. So after graduation, most likely you will find a job in industry, or unless you go to academia, then this is very interesting. Huh? You want to work for better jobs and I mean, of course, meaningful jobs, of course, but you probably want to have work for more interesting industries. And I think this graph tells you something. No? Another point of view, which is from research. So, so departing from industry and practice, so now looking into the research. So what are prominent research topics when it comes to services? So services are broad. That can include, for example, healthcare service, governmental service, and so on. So among those various types of service research, this graph shows what are more important research topics within the vast area of services. And the result indicates that PSS received the most important topic as recognition. This data comes from a survey in Japan where a few thousand responses were given and analyzed, 2/3 coming from academia and 1/3 responses came from industry. So they sort of see the possibilities and potentials of doing PSS research in the coming future, right? So I would like to ask you now, because I have shown the 9 slides, each of which hopefully was interesting to you. Did you see any new information? Did you see any surprise, or did you know all of this? So what's your response to those 9 slides? Don't be shy, and although it's recorded. Anyone?
So megatrends in Sweden.
Megatrends in Sweden. Yeah, okay.
Netflix, Spotify.
Yeah. So I think IT industry it has a very important role in PSS, which we will touch upon in the course as well. What else? Okay, you will have more opportunities in the rest of the week. Okay, then in the coming few slides, I would like to address environmental issues as well. So as a citizen, as a consumer, you use different types of products every day, as you see here. They require natural resources, obviously. And when the products are used and reach at the end of their life, then many of them are landfilled. These two aspects both create environmental problems. Huh? And as a consequence, we see different pollutions and also, for example, water accessibility issues. These are big challenges, as you know. And manufacturers do influence a lot on this, because the reason why these problems happen are partly attributed to these manufacturing, right? So manufacturing industry must take an action to address this important issue. And PSS has a big potential to address this problem. And with that as a background, the European Commission issued a Circular Economy Action Plan back in 2020. Now I think they are in the phase of publishing the next version of the action plan. But if you look at what the Commission says, is very much designed for durability, product life extension, and also product as a service is spelled out in the action plan. So the Commission wants to see more product service system businesses in order to facilitate, in order to accelerate the transitions to a circular economy. And if you look at what the Commission has done so far, a lot of efforts have been put into material recycling, and there is a clear gap in the circular business models that include product service system, product as a service, that kind of business styles where value creation can be decoupled with material consumption, material use. So that is why the Commission sees a lot of potential in product service system design. And looking into the academic research, Chestin 2016 paper provides an interesting figure that explains the sort of trends of research over the years in terms of systemicness on the horizontal axis and let's say the relevance of people on the vertical axis. So many years ago, the Design for Sustainability research area started at the product level, and then that evolved over the years up to PSS level. That was the sort of history, and then the trend could be moving into spatial social level, and even to a higher level, which is socio-technical system level. So looking at the typical research area such as eco-design that was typically addressing product design, material choice, and disassemblability, those kinds of issues were addressed. And they are very important and still important, but sort of academia realized that the problems are more complex. As I showed you in one of the first slides, the requirements, demands from the societies have become so complex, more complex, so that products alone cannot address such challenges enough. So therefore, the research area, so-called sustainable PSS, has emerged. And then other possible topics like social innovation and socio-technical system innovation are also becoming relevant. So this graph shows sort of trend showing the research object has become larger, broader, so that more holistic improvement and optimization, if you like, must be addressed. So this is, I think, an important trend that you should keep in mind. So now, coming to the central concept of the course, PSS. This picture is taken from Bain's 2007, which has been used very much by a number of people, which I think clearly shows the fundamental difference between two business styles. One is selling products, the other is providing PSS. So on the upper half, you see selling products. You as a manufacturer provide products to the customers. Customers use the products. But that's their business. No? That's the customer's business. And the manufacturer get paid by providing products. But on the other hand, when it comes to providing PSS, what is more important, what is more relevant is not the product as such, but the outcomes of the product. So this is what Levitt referred to, right? So the customers are also interested in outputs, not the product as such. So this is the interface between the provider and then the recipient, right? And this creates a sort of trick where higher value for customers can be expected, and also the lower cost can be expected for the provider, and also there is an environmental potential improvement. This is probably sounding like a magic. No surprise to hear such a response, but I try to explain to you why this can happen. And there are different mechanisms to make this happen. So meaning that this doesn't automatically happen. Huh? You need to design something, products, services, and systems, so that the systems as a whole make this possible. And this is not easy for manufacturing organization or any organization to realize. But I always say, especially to companies, because this is not easy, therefore this is interesting for you. If it's easy, every company will do it, right? And one of the implications of this is more types of actors should be involved in PSS business compared with product sales business, which means that you are expected to create a value co-creation system, sort of business ecosystem, where the manufacturers, providers' commitment should be enhanced, and also in return, they have a higher potential to get more value captured, both for the provider and for the customers as well. Okay, so I hope this difference is clear to you. Okay, so this is quite important to understand. And in the inauguration ceremony, we heard that this course or program, maybe program as well, is multidisciplinary, interdisciplinary nature. And I think that's true, especially for this course. And this slide aims to clarify a little bit about possible confusions between similar terms. One is multidisciplinary, and then interdisciplinary. And also there is another term called transdisciplinary. To start with multidisciplinary, it's a most simple one among these. So there are, let's say, multiple disciplines. And let's say there is a problem in industry or in society. And then the problem must be solved by using different bodies of knowledge. Okay? So once the problem is solved, then it's fine. So the knowledge remains as it was. But when it comes to interdisciplinary research or research and innovation, in addition to what happens with multidisciplinary research, so the interaction between different disciplines happen. Huh? You will hear examples in later slides. So these interactions create an opportunity to solve the problem better. Okay, so that's the difference. And then what about transdisciplinary? So what is in addition to the interdisciplinarity is, as a result of research and innovation, a new body of knowledge emerges. So this is the characteristics of transdisciplinarity. And what is a little bit complicating is there is another meaning of transdisciplinarity, TD. Sometimes TD is used for the character of interaction between the academia and industry. So it's a little bit confusing, but do understand TD is basically building upon interdisciplinarity, which builds upon multidisciplinarity. And TD1 and TD2 are features, meaning that both features can exist for a given research and innovation at the same time, right?
What is discipline creation?
But
What is discipline creation?
disciplinary creation? Oh yeah, okay, this one.
Yeah.
Okay, yeah. So this means what I said as sort of new discipline emerges. I have prepared one slide of the new discipline creation. So the funny thing is, unfortunately, I think this used to be the case often, at least some decades ago. But now, I think the university has a sort of expectation to contribute to solve the real problems in industry and society. So this shouldn't be the case anymore, right? So I wanted to show this to you because it's a bit funny. It's cynical and funny. So we want to break this. Huh? So this is an example of discipline creation or emergence of a discipline. Everybody knows mechatronics, right? Everybody agrees to this is a discipline? Yeah, I think so. It happened, the emergence of mechatronics as a discipline happened in late 1960s with the feature of TD1 and TD2. So industries wanted more than what is possible with the mechanics and electronics. So industries wanted more complex movement, complex control, and thereby academia developed knowledge for how to realize this by combining mechanics and electronics. So you see an example like this, no? Have you seen this kind of mechanics? It's fascinating in a way, right? If we see from our contemporary common sense. Now you see this kind of mechatronics machines is more common, right? And when realizing this kind of control and measurement and control and movement, mere combination, mere accumulation of mechanics and electronics was not enough. So the two disciplines must be interacted with each other so that this measurement and control was realized sufficiently. So this is one example of emerging new discipline. So I hope this was rather interesting to answer to your question. And I, together with two other colleagues, wrote a paper about 10 years ago. So it's like using different sets of crayons when doing TD1 and TD2. So you have an opportunity using a set of crayons and another set of crayons, and to draw a picture in order to address the challenges from society's industry. So this is a metaphor of TD1 and TD2. And when doing research, especially when creating TD2 knowledge, it's important to recognize the two sides, one of which you belong to, scientific practice, and you have partners from industry, from society, from the other side. And typically, in doing this kind of research, you need to frame the problems, and also you need to know each other, and then the research process is not straightforward. It often sort of the balls come back and forth between the two sides. The reason is quite obvious, because each side has its own mission, has its own motivation. So they are different. So the collaboration is not easy. But that is why this process makes so interesting, creating an opportunity to create new knowledge and also new solutions. So keep this in mind when you do research of, for example, product service system, especially in the context of industries, and you need to interact with industries and so on. This is important to remember. Easier to describe and explain, but very difficult to realize. We always realize this, but important to bear this in mind. Okay, then I think I have some more slides, unless you have any particular questions so far. I will move on. PSS is at least a multidisciplinary domain, which involves design, engineering design particularly, and also, for example, marketing and other disciplines as well, business administration, etc. And this chart is taken from Uraga, 2010. Marketing scholar, they described what are needed for product service system by manufacturers. They didn't use the term PSS, but they meant exactly the same thing. So from the marketing scholar's point of view, what are required as distinct capabilities for a manufacturing organization moving to PSS is these 5. And one of these is design to service capability, which is exactly about PSS design. And another relevant thing is risk assessment and mitigation. This is also relevant to a few topics you will be listening to, you will be learning in this week, how to address different types of uncertainty and risk management, and so on. Why I showed this is that, interestingly, different disciplines indicated that design is so important in this context. When manufacturers provide services in their business offerings. Okay, so this clearly indicates the importance of design in this context. So then, when it comes to designers, I want to ask you who they are and what they do. Who are they and what do they do? You can meet those people in this kind of environment. I mean, nowadays perhaps they work at home as well, but in many cases they are found in this kind of environment. So who are they?
Designers are creative individuals. They do problem solving.
Oh, great. Creative individual, problem solving. Very good, I think, introduction to what I referred to from John Jarrow, 1990. They are change agents in society. And they make physical change in the society. So this is, I think, a very suitable definition of who they are. And this applies to PSS designers too. And they make changes in society, and they make some sort of physical changes, which doesn't mean what they provide are always physical, but through their activities, some physical changes do happen. So this is a message. And what you will learn in this course is quite a lot about procedures, design procedures, using different methods and tools. And why is this? Because this is one of the powerful opportunities for us knowledge creators, academia, to make an influence in industry. For example, a procedure can be implemented in company A, saying that company A management says that, okay, whenever you run a project, you need to follow this procedure. Okay? So procedure can be described as different steps, for example, and then in each of the steps, you need to do this and this and that. This has a very powerful influence because all the projects in company X will change. And we academia have an opportunity to influence that procedure. Okay? Because typically, at least my group, my colleagues are not working on typical sort of R&D aspects like new materials, etc. We don't do this. But we have a very sort of effective ways of influencing companies' design, especially. So this is why you will hear so much about procedures, methods, and tools. Okay? And also, when it comes to when of design, it's important to remember the importance of front loading, meaning that the earlier stage of design is more important in terms of influence on the outcomes of design. This graph is taken, it's a very classic textbook representation by Sullivan. And this graph compared, back in 1980s, compared the product development between Japan and US, especially in the automotive industry, when US industry, manufacturing industry, suffered a lot, lagged from Japanese car manufacturers. And then they looked into why the difference, the huge difference happened. And one of the things they identified is the difference of the efforts put into in different phases of design. So in the case of Japanese company, they make more design changes, engineering changes in an earlier phase so that the problems are fixed as early as reasonable. Whereas US companies turned out to make a lot of more changes than Japanese companies in a later stage. And this causes a lot of additional costs in terms of course, time. So that is, of course, not efficient. So the important thing is you need to make decisions as much as possible and reasonable in an early phase of the design. So that's why you hear a lot on the methods and tools that can be applied to early stage, right? And if I describe the sort of the changes realized in the US at the time is this, because in the sort of older system in the US, they spent more time in redesigning of products. But after learning methods, especially quality management, they spent a bit more time in the early phase, and thereby they succeeded in reducing the total lead time for the product development. Okay? And that kind of knowledge is still used. This is a graph of our contribution to the British Standard in Circular Economy 2017. So that similar knowledge is applied, meaning the influence on the environmental impacts, environmental burdens is also influenced a lot by the early phase of design. With that, I think we can close this lecture. Before that, I would like to take any possible question that you may have for the first lecture. Yes, please.
So what exactly is front loading?
Pardon?
What exactly is front loading?
Ah, front loading. Yeah. So it exactly means that you are expected to collect information as much as possible and make decisions as much as possible in the, let's say, front stage, in the early phase of design. So that's usually called front loading. Yeah.
Do you think that is better or iterative process?
It's the iterative working is not really against front loading, and that's a, I think, very interesting question. And front loading shouldn't mean that everything should be decided at the beginning and shouldn't be revisited. That's not what the front loading should mean. The important message is that you should at least consider as much as possible at the front of design, and probably you should leave some of the decisions open in the front, and those should be decided later in the design phase. And thank you for your question, because I have prepared one graph I will use in later in this week in relation to product and services. Thank you. More question? Yes.
So here in the graph, the American graph, after the launch there is sudden spike. What does that indicate?
You mean this one? Yeah.
Spike.
Yeah, this means that the customers call company that, hey, I have a problem in my car and fix this. So that's what this means. So the company needed to react to solve those problems. and then they make changes even after the product launch. Yeah.
That means in Japan there is no change.
From this graph and the sort of research procedure of Sullivan is a little bit unknown to me. I don't know how he collected the data behind this figure, but more or less this is a picture that they want to convey as a message, especially to US companies. And this is a so much known figure, and well, basically many people agreed to this. Yeah. More questions? Yes.
But this process doesn't work for every industry, right?
Once again, please.
Like this engineering process, if you come into software, if you are building a product, you are not able to get upfront complete inputs and as the product launches, you'll get more inputs, more than needed.
Yeah.
It will be an ongoing process.
Yeah. That's a very good point, because when this graph was made, it was many years ago when software is less relevant than now. And I think that is a very interesting research area, how software development should be conducted in parallel with product development. And thinking about the offerings from car manufacturers nowadays, a lot of software updates are provided. That happens, of course, even after the product launch. Product remains the same, but softwares are continuously updated so that the function received by the users evolves over time. No? So this is quite different from the picture drawn by this. No? That's a very interesting aspect. And again, in relation to the previous question, I would like to address that in a later course in this week. Yeah. Okay. Yes, please.
Would it be right to say that the increase, I mean,
Yeah.
the graph being at that level for US companies is because of, say, unaddressed problems in the initial phase and or wrong decisions that were taken that
Yeah.
had to be corrected?
Yeah, I think this high number originates from both of what you said, unaddressed issues and also wrongly addressed issues. Yeah, I agree to you. Yes?
At the very start of your
Yeah.
slides, you mentioned a lot of companies, Bosch, Siemens Energy.
Yeah.
And you mentioned one common point of it,
Yeah.
that products come with services.
Yeah.
So according to your opinion, what is the main goal of all those companies?
Yeah.
Is it to make money, to generate revenue, or is it something else?
I mean, obviously, those are all profit-oriented organizations, meaning that profit must be one of the top priorities of their agenda. No doubt about that. What is, I think, interesting, especially in the last 3 years or so, is that those companies are receiving high pressure from especially shareholders regarding the effort for improving sustainability aspect of their business, products and services, and also their activities too, which is not exactly the same as economic, financial success. No? So the companies are forced nowadays to make efforts to improve the sustainability aspects as well. That is quite outspoken in the last years. So there are different types of motivations, purposes of each company. And it's not only financial aspect, and I think it's quite nowadays complex to address those missions and purposes. Yeah. Okay, any other question? And we could.
Tea break and then
Yeah.
we have the answer a week.
Yeah. Thank you for your engagement. I felt this is a very good start, and let's look forward to the next activity. Thank you very much.